is EM. Or you might want to just call it light energy, whichever one you prefer. Alrighty. So it says here, practice. Let's look at the practice here. A runner eats pasta before running a marathon. Well, that's an example of chemical energy to kinetic energy, or again, you might call it mechanical energy. Battery operated clock. Well, in that case, it's going to be a chemical energy. And what happens here is that the clock is going to move. Well, it didn't tell if it's a digital clock, which would be chemical to electrical because it would give off the light, or if it was the kind that, tick, 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 because it has a second hand on it, two hands. So it could be kinetic energy or the mechanical. They were not very specific, so we don't know. It could have been not this. It could be electrical because that digital clock is showing the light of the time. A hair dryer is electrical to thermal, right? Dries your hair. A solar panel. Ooh, what's a solar panel? A solar panel is going to be nuclear to light. Most of the time, I'm thinking solar panels on a house, or those solar panels when you come to a school zone, they have those little solar panels, that nuclear heat energy. Now, some people may not have said this nuclear energy. They may say light energy to light energy, or to mechanical energy, or to kinetic energy. The problem here is that when you're going from one type of energy to another, sometimes it's kind of difficult. It could be this or that. And the reason why is because in the beginning of this section of the notes, we said that many times there are more than one type of energy that are present at the same time. So that does kind of make it a little tricky. Which energy transformation occurs when a fluorescent light is turned on? So when a fluorescent light, so if I was to just have a lamp, I guess, if we were to say that, or the light switches in the classroom, if we were to turn on the light switch, that would be electrical energy to light energy. All right. Campers are roasting marshmallows on the campfire when one of the marshmallows starts to burn. Which of the following statements is true concerning that marshmallow? So energy is destroyed. Oh, whoa. Cannot be that answer. The total amount of heat and light energy released from burning is the same as the potential energy of the marshmallow being burned. Whoa. That actually is a pretty good statement. The amount of light and heat energy is greater. Whoa, can't be greater because everything is equal. So that's not going to work. Energy is created. Whoa, energy cannot be created. Correct answer is B. Okay. A plant using sunlight to create glucose during photosynthesis is an example of, solar energy being converted into chemical energy. D is the correct answer. Now let's talk about energy, and we're going to break it up a little bit because I think before we started all those different types of energy, it said that all energies are categorized into two groups. What are those two groups? It said on our notes. It said potential or kinetic. And those are the two groups. So our first topic here is energy. It's broken into two groups. The SI unit for energy is a joule. Now, the kinetic energy is energy that we call in motion or moving, right? And potential energy is what we call stored energy. Now, kinetic energy is energy in motion. And the formula, there's actually an equation which is, and you did this equation, I know for sure in middle school. 1/2 times m times v squared. That is the equation. Now, potential, though, we've got two types. We've got one that is due to height, and that's the one you talked about in middle school. The other type is going to be due to stretchy, and that's a new one. Okay? Now, if it's due to height, we call that gravitational potential energy, or GPE. If it's due to the stretchiness, we call that elastic potential energy, or PEE. Okay? Now, the equation for GPE is mgh, and the equation for PEE, which is a new equation, you've never talked about that one prior to now, is 1/2 times lowercase k times distance squared. Alrighty. Now I will video some more and post those later, but I think that's about as far as we can probably get to in our notes at this time. It's definitely going to be enough to answer the next set of homeworks. Alrighty, have a good day.